Before we look at the page out of the book, I just want to show you an idea about all the different strategies that you can use in order to solve proportions. It's one really nice thing, and then it gives you a lot of choice. It's important that you learn how to use the different strategies, and then once you know them, you can use whichever strategy you think best fits that situation. And that will be the ideal strategy for you, not any one that you're told to do. But first, you just got to learn those strategies. Let me show you an example of the same proportions and how I can solve them in 4 different ways. There are more than 4 ways, but these are maybe the 4 most commonly used methods and maybe the easiest. So anyhow, I chose numbers that you can visualize in your head, big but not too big, and so you'll kind of get an idea of why this works because you're able to visualize these specific numbers I chose. So anyhow, let's look at the first one, 5/25. How many 50ths? So there is the standard algorithm for proportion, and that would be this. It's where you cross multiply. This is the standard algorithm. So you get 25 times x is 25x equals 5 times 50 is 250. So to get the x by itself, I divide both sides by 25. That cancels out. And 250 divided by 25 is 10. So that is the standard algorithm for finding a missing value in proportionate fractions. So now let's look at this one. This is the method that you probably would have chosen to use first. It's what I would use. You do like equivalent fractions. 25 times what is 50? Well, 25 times 2. So then this would also be times 2. So then x equals 10, because 5 times 2 is 10. Here's another method. This is not one I tend to ever use. Actually, I have used it a few times, but it's not one I use right away. It's one that when the most obvious don't work, I'll think back on. So that is going from here to here. If they're proportionate, it's going to be the same going from here to here as it is from here to here. So how do you go from 5 to 25? Times 5. So then it's going to be x also times 5 equals 50. And what times 5 is 50? 10. And then the last way, and this is a way you can actually use with all of the other strategies. It really isn't necessary in this one, but in a lot of other ones, it is the most beneficial thing you can do. No matter how you solve a proportion, if you have big complicated numbers and you can reduce, just reduce. It'll make your life infinitely easier. So I see that, and I can't reduce this side obviously because there's only one number. You have to have 2 numbers in order to reduce. So both of these numbers are divisible by 5. So I can reduce this to 1/5. Now, when you do that, it's a really good idea if you rewrite the whole thing, just so there's no confusion or you know something got messy and then you didn't know what number it was, whatever. But then you can use any of these methods. You can choose, you can do the cross multiply, and it would be 5x equals 50, or you can do, this method, it would be 5 times 10, 1 times, so, anyway, you get the idea. I guess my point is, reducing one of the fractions will work with all of the different methods to make them easier if you need it. On page 8, I'm going to solve 3 here with you, and you can do the rest, of course. I'm going to use the method that I just think of using first. No specific method. So look at the first one. 2/18 is equal to how many 36ths? I'm going to reduce by 2, and that's 1/9. Then I'm going to rewrite the whole new fraction over here. 1/9 equals x over 36. And from here, it's really obvious that 9 times 4 is 36. So 1 times 4 is 4. So then x equals 4. You see that? 3/5. Well, I can't reduce that, but that's just as well because it's really easy to see that 5 also times 4 is 20. So then 3 times 4 is 12. So x equals 12 for number 3. It's nice if you could write what x equals. So it's really easy for me to find your answer and circle it too. That would be absolutely wonderful. Now the last one, number 9, I just kind of randomly picked some of these. I am going to reduce by 3. 15 divided by 3 is 5. 18 divided by 3 is 6. So then my new ratios are x over 3 equals 5 over 6. So you can tell pretty easily how to do that. But you might be a little confused because times 2 is 6, right? X times 2 is going to give us 5. What times 2 is 5? Gosh, I don't know. So you could do some division and do some other stuff, or you might look at this and change strategies. Let's say I don't know what times 2 is 5. So then what I suggest you do is take a whole new strategy. That's something that you need to be able to do with proportions. When one strategy doesn't work like you think it should or you want it to, do you have another strategy you can use instead? So what I'm going to do in this situation is I will rewrite it the way I had it after I reduced, because you can reduce with any strategy. Reducing is always a good thing. So now I'm going to do cross multiplication. I think it would be easier, like that. 5 times 3 is 15 equals x times 6 is 6x. Now I want to get x by itself, so in order to do that, I'll do the opposite. So the opposite of times 6 is divided by 6, which I have to do to both sides. So now I have something that equals x. 15 divided by 6. Well, let me figure this out. 15 divided by 6. This is definitely not going to be a whole number, as if I hadn't already figured that out. 6 goes into 15 2 times. 2 times 6 is 12. The remainder of 3. I'm going to divide it out. 6 goes into 30 5 times. 5 times 6 is 30. Okay. Bring up my decimal. Ha! My answer is 2 5/10. Ha! I figured it out. In this case, x equals 2 5/10, or 2 1/2. There we go. I did a lot of work around here, so nice to be able to circle my answer. For page 9, we'll do 2 together and the rest are on your own. That gives you 4 altogether. The first ones are essentially the same as what you've already been doing. So this shouldn't be any issue whatsoever. I am going to do the equivalent fraction method. Let's see, I'm going to go this direction. So 12 times 3 is 36. So 5 times 3 is 15. So then I know n equals 15. That is my answer. So that's a super easy one. They're all equally simple, I think. So number 1. So it's when you're looking to make equivalent proportions, or should I say proportionate ratios, it can be a little daunting when it's in that format. So what I strongly suggest you do is write these as fractions. So 20 is first, so I'll put 20 on top. 20 over 14 equals 40 is first and x is next. Like that. Now it's a whole lot more obvious to see what it is. So how do I go from 20 to 40? Well, times 2. So then this will be times 2. 14 times 2 is 28. So then the equivalent ratios written like this would be 20, 14 equals 40, 28. Just like that. Got it? So do that on the next two and you all see it.